like we did before, because it's gonna be like a three rows, 9 columns, or 4 rows, 8 columns, I mean, it's big. But you're only going to pivot a certain column. Once you're done, and I'll tell you how you know when you're done. So you could do it by hand, or you can use the calculator. All the calculator does is it gonna do the row operation for you. Because if you love fractions, go for it. Okay, now, when I took this class, yes, simplex method was still around. It started in 1947. So I took it, there was no calculator. You did it by hand. There was no program that would do it for you. So it's like the last test, okay? Except we're going to solve it a different way. We did it graphically, but graphically has its limitations because you can't use real large numbers. I mean, if there was a limit of 40,000, you can't do it, but you can do it using the simplex method. So what we're gonna do first is a standard maximization problem. Then we'll do the standard minimization, and then we do the non-standard, and then it's test time. Because that's it for a simplex method. And I will let you know on Tuesday when your test is.
How many tests do we have left?
2, and the final. So basically, we have 2 weeks, I mean, you'll do it probably within 2 weeks, you'll take your test. And then,
I'm sorry.
yeah,
Do we have to take our final?
you can get a 0 for it.
I didn't know if it would, cause I know that it
That, not in my class. Everyone has that unique opportunity to take my final exam. It is worth 200 points. So if you have an A average, you can drop down to a C.
Oh, Jesus.
No, because we don't take it. It's a 0.
Okay.
Do you have that handout? I didn't have it in mind. Did you get that?
Which one?
What you're fixing to go over?
I am sorry. Yes, I did.
Thank you.
Sorry. Okay, so, this is a requirements for a standard maximization problem. Did you not get one either? Oh my goodness, I'm sorry. Function is going to be maximized. Each linear constraint inequality has to be less than, or equal to, but still less than. And all the variables, x, y, z, they have to be greater than or equal to 0. The non-negative constraint, that has to happen. So the objective function you are maximizing, all the inequalities are less than or equal to, and the non-negatives are greater than or equal to. That is the requirements for a standard maximization problem. Okay, listen, and then I'm gonna show you how you do it. What we're gonna do is we're gonna take these inequalities and then we're gonna rewrite them using what's called a slack variable. Okay. So let's say I had an inequality. I'm gonna make one up. Alright, now, granted, I should have a y, but let's just take this for example. So, would 1 work for that inequality?
No. Oh. Oh, yes.
Yeah, cause it still keeps it less than 5.
Yes.
Would 0 work?
Yes.
Yeah. But what if I wanted to find the exact value that would work? And there's only one of those.
2.
2. So if x is 2, I've got an equation. I don't have an inequality. but I don't know necessarily what it's gonna be, especially if I have X and Y. If I knew X was 2, that's an equation, because 2 plus 3 equals 5, but I don't know what that number is. If I have X plus Y is less than or equal to 5, I don't know what X and Y are, and then I need it to be an equation. So we come up with what's called a slack variable. To rewrite an inequality like an equation, you're gonna say X plus Y plus U is equal to 5. So, if X is 1, Y is 2, okay? U would be 2, and I have an equation. If X is 3, Y is 1, U is 1, and I have an equation. Okay, I don't know what these numbers are, so I get this slack variable called U, okay, to make this into an equation, and I can solve it. And I'm gonna solve it using Gauss-Jordan row operations. It is fine.
That's what you just gave us for.
And I am going to work it by hand. If you don't hush, you will be too. I'm not gonna show you how to use the program. So, and as you know, we just don't have one inequality, do we? No, we have a bunch. The X and Y greater than or equal to 0, you leave alone. It has nothing to do with those. We're only looking for maximization, we're only looking at the ones that are less than or equal to. But even if it was minimization and they're all greater than, the X and Y that are greater than or equal to 0 are the non-negatives that you have to create these problems. You leave those alone, just like we didn't, we did. All right. So what we're gonna do is, I'm gonna give you the inequalities, we're gonna rewrite those as equations, we're going to then do something with the objective function, and then we're gonna create a matrix. Remember matrices? They weren't too bad, except for Gauss-Jordan, but it's okay. Then we do, using Gauss-Jordan, the process called the pivot process. The pivot process is where, and you'll know which one it is, you make one of the values in this column a 1 and the rest zeros, you have pivoted it. That's what pivoting is. Where you take a column in a matrix, and you'll know which one it is, you make one of the values a 1, everything else is a 0. When you do that, that is a pivot. That is what pivoting is. That is why your program is called the pivot program. All right, you ready to, I have to explain how to do it. The only really way to explain it is to show you. It is there are steps to do this. It's strange, but once you get the gist of it, it works fine. But it is strange. Okay? Not that we haven't done other strange things in this class. So, turn the page, and I know that this is the entire process. But if I ask you, what do you use to change an inequality to an equation? It is a slack variable. You can actually use it. You can't use X or Y or anything that's given, but you can use any. Now, I'm gonna give the typical values for slack variables. I don't like the way the book writes it, so I'm gonna use the way I write it. Here's a linear programming problem. We've actually, we've already done this, graphic. So we're gonna maximize the objective function, 2x plus 5y. It is subject to constraints. What are constraints? Constraints are inequalities. 2x plus 3y is less than or equal to 12. 3x plus y is less than or equal to 12, and x and y are both greater than or equal to 0. This part you leave alone, but it has to be given to be a maximization problem. So we're gonna take these and we're gonna rewrite these, as equations. And I'm really just gonna do it over here because I don't have room. Yes, I do. I can't read. So, we have 2x plus 3y plus u is equal to 12. No more inequality. Excuse me. 3x plus y plus v is equal to 12. Slack variables have to be different for each equation. So then I would use w, I would use p, r, anything but not x and y. And all the slack variables have to be different. Then I have my objective function. What I want to do with my objective function is I want to bring the right side over to the left. So I'm going to have z minus 2x plus 5y is equal to 0. And that is my z. Okay. It's like the p profit.
But where did they come from?
It's up here. It's way up, look at the top. It says z is equal to 2x plus 5y.
Oh, I see now.
Yeah.
Why is it z minus 2x?
I want the z positive, and I want everything over on the right side come over to the left. That changes their signs.
So would it be minus 5y?
Yes.
I just wanna make sure. It's confusing.
Thank you. Now, that's step one. You rewrite the equations. We're gonna put it into a matrix. And this is how the matrix has to be written. Make it a big matrix. Remember how I used to write X, Y, Z, and I said, this is the X column, this is the Y column. When I'm done, I'm gonna have my X column, my Y column, my U column, my V column. My slack variables have to have columns. My Z or P column is gonna be P when I start doing work columns. And my answer column. So, first equation is 2, 3, 1, 0, 0, 12. Second equation is 3, 1, 0, 1, 0, 12. Put a straight line across. What's wrong? You gotta have that straight line across. The last row is gonna be the objective function. -2, -5, 0, 0, 1, 0. We okay so far? Good. Now, I'm not solving this, if you want me to, we can solve it. But if I say, like you're gonna get your quiz on Tuesday, and it's a real quiz, I'm gonna ask you to set it up, find the pivot element. And this is how you find that element, and you're gonna put a box around it. And then you stop. Now, we can solve it by pivoting, but right now, I just want you to find it. To find it, look at the bottom row, and you're gonna find the most negative. Ready? So imagine that there were no negatives on the bottom row. What's the highest number? 5. So that is my most negative number. That tells me this is my pivot column. Somewhere in that column, I'm gonna make a 1 and everything else 0. Okay. I need to know which one I'm gonna do. Now, the bottom row is never pivoted. The objective function is never pivoted, just like it's never graphed, it's never pivoted. This is how you do it. Can you see the last? Okay. You take this divided by this. This divided by this, 12 divided by 1 is 12. I took 12 divided by 3 is 4. 12 divided by 1 is 12. Which one's smaller? 4 or 12? 4, so it's on the first row, so this is my pivot element. That is the one that has to become to be a 1, and everything else is 0. It has nothing to do with that's 1. That's nothing to do with it. Bless you. Now,
Thank you.
this is how you did it. This is how we do it. Look at the bottom row, find the most negative. It is -5. That's your column you're gonna use. Then you're gonna take your answers, use the column that we chose, divide them, and find the smallest number. That is your row. This tells you it's this column, it's this row, and you make a box around it. So when we do the pivoting, that's gonna become a 1 and these 2 zeros. You never make this a pivot element.
So 3 is the pivot element.
Right. But you gotta put a box around it. Okay, that's just the requirement. Because what I'm gonna ask you to do, I'll give you the inequalities, you write the equations using the slack variables, you write the matrix, and you're gonna put a box around the pivot element. You first find the column, then find which row, and it's always the smallest. Now if, just say they were both 4, okay, they both turned out to be the same number, you just choose one. It doesn't matter which one. All right, so now we're gonna try this. Of course, it says we're gonna maximize z is equal to 5x plus 7, subject to, 2x plus 3y is less than or equal to 15, 4x plus 5y is less than or equal to 35, and x and y are both greater than or equal to 0. Step 1, rewrite the inequalities using slack variables. So I have 2x plus 3y plus u is equal to 15. 4x plus 5y plus b is equal to 35. Not done. The objective function, bring those numbers over to the z and they become negative. And you set it equal to 0. So the objective function has to be set equal to 0. However, that z value has to remain positive. Okay? Not done. Next step, we're gonna create a matrix. Alright, so I have 2, 3, 1, 0, 0, 15. 4, 5, 0, 1, 0, 35. Then my objective function, -5, -7, 0, 0, 1, 0. Now, even though the 5 and the 7 are not lined up with the x's in the equations, this is my x column, so everything in here had to have an x variable. My y column, everything in here had to have a y variable. My u is because this has my u in it, this has my v in it, and my z. You make the first one 1, everything before this line has to be 0, and then you write the answer to the equation. Second one is 0, 1, 0, then whatever the answer is. And then 0, 0, 1, 0. It's always like this. This is the identity matrix. So it has to be written that way. All right, not done. First I'll do my column. Most negative is -7, so it's column 2. Then I'm gonna have 15 divided by 3 is 5. 35 divided by 5 is 7, so this is my pivot column. And I'm stopped. Now we're not finished. We're not finished, okay? But for your quiz, when I say set it up, do not solve it, that's what I want. I mean, you have to put a box around the pivot element. Is it strange? Yes. Yes, ma'am?
When we find the pivot element, are you looking at what's smaller? Like
Yes, the smallest ratio,
Okay.
okay? This one is the most negative, and then you have to find the smallest ratio. And this ratio has to be positive. That means if for some reason you have a negative number, you can't use it. It has to be a positive ratio.
So is it what's smaller between 5 and 7?
Yeah.
Okay.
So whenever you're telling us to set it up, this is as far as we go with that?
That's it. Okay, so far?
Did you just say that if the number was negative, we can't use it?
If we do this ratio, over here, they can't be negative. Here, we want them to be negative, because I've gotta find that column. And actually, we made them negative.
But if they're not negative, we just find the largest number. Because you said the largest negative number, but if it's not a negative,
Should be the smallest number, wouldn't it?
would it be the smallest number to absolute?
I think it's always gonna be negatives, right? Wouldn't it be,
Okay, hold on, so are you saying that you're just not supposed to get a negative when you do that?
No, nope. Today, we are maximizing.
Yes.
We will have negatives.
Okay,
Tuesday, we will minimize. We will not have
Okay.
negatives,
okay,
okay? But there's a different way to do it,
okay.
okay? So I'm not gonna say 100%, but when you maximize a standard maximization problem, you will have negatives in the bottom row. And if you have a negative over here, you can't divide, because it would make it a negative value, and that's not one of the values you can use.
What do we do if it is a negative?
You wait till Tuesday, okay? Now, at the process of pivoting, you know how I pick my most negative and I'm gonna pivot, I'll make my one and the rest zeros. You can't just change one column. When I do this, the whole thing is gonna change. When I do not have any more negatives in the bottom row, I'm finished. Now, you could pivot 4 or 5 times before you finish. Okay, so you can't just say, all I have to do is once. No, maybe for this one twice. But what if you had 4 or 5 inequalities? Then your matrix is gonna grow. So turn the page. Oh, that's the same problem. Well, you don't really need to do this. Yes, we do. I'm gonna show you how to pivot by hand, okay? Then I'm gonna show you how to use the program, all right? And I'm gonna tell you, I don't think I gave you the homework. You're welcome, because it's gonna rain all week. So, I'm gonna show you how to do it by hand, because I think anytime I work it on a handout and I post it, it's going to be worked by hand first, then using the program. Now, you can get confused with the program, okay? Also, when you work this and you're using the program, if you have to pivot again and you have to find the ratios, you need to have a different calculator on a hand. One that can add, subtract, multiply, and divide, and that's all it needs to do. Okay, that's all it needs to do. Only because you're in the program, you cannot get out of the program, you have to stay in the program till you're finished. So you need to find that value. So, this is the first one we did. I have 2x plus 3y plus u is equal to 12. 3x plus y plus b is equal to 12. And negative 2x minus 5y plus z is equal to 0. You can write it this way, or you can write the z. This has everything lined up to write your matrix. So, the difference from, we know which one is a pivot element, and we're going to pivot. If you just wanna watch me, that's fine for the first time, but just know I am a true believer. I love Gauss Jordan. So, I think it's fun to do. I know. You can just think what you want, but I will also show you how to do it on the calculator. So, this is called the initial tableau. Please don't ask me why they use this name. It's for your matrix where you have set it up. Now, I'm gonna tell you, when you take this test, I give you a matrix, and I tell you which is your X column, which is your Y, which is your U, which is your V, and so on. You don't have to put those on there if you don't want. I just keep everything in order by putting those. And we found the pivot element, 3, 0, 1, 0, and negative 2, negative 5, 0, 0, 1, 0. This is my pivot element. So that means when I'm done, this will become a 1, this is 0, and this is 0, when I'm done. Now, we're not gonna make a whole column of zeros, there's gotta be 1, 1, and everything else zeros in that column. Well, we're gonna use row operations. So, how do I make a 3? In Gauss Jordan, multiply.
Yeah, do that.
Multiply by 1/3, the red, heck, I don't know what it's called.
I gotta go back.
Here's when you flip it, I'll think of the number. So it's 1/3 times row 1. That is the whole row has to be changed by multiplying by 1/3. You just can't change that 3. That whole row is gonna change. So it's 1/3 times row 1. It's my new row 1. That means every element is gonna be multiplied by 1/3 or divided by 3. So it's 2/3, 1, 1/3, 0, 0, 4. And -2, -5, 0, 0. Now, guys, I'm gonna show you how to do it on the calculator, but in all fairness, I need to show also how to do it by hand. Am I done? No, because everything below that 1, the top 1 has to become 0. To make a 0, I add the opposite. So I'm gonna take row 1,
Can you move that to your left, please?
left,
No, all the way there.
your left,
Yeah,
this way.
thank you.
Not done. So what I'm gonna do is -1. Why? Because what's -1 plus 1? 0, but I have to do it to the whole row. So I'm gonna change row 2. So I have -1 times row 1 plus row 2 gives you a new row 2. So, okay, so I have -1 times 2/3 is -2/3, and -2/3 plus 9/3, 7/3. Row 1 isn't gonna change. 0, 0, 4. Hang on, I got it. -2/3 plus 3. And 3 is the same thing as 9 divided by 3, it is 7/3. -1 plus 1 is 0. -1/3 plus 0 is -1/3. -1 times 0 is 0 plus 1 is 1. These are all 0. -4 plus 12 is 8. And we have one more to do. That is to make this -5 a 0. So, what can I add to -5 to make a 0? 5, so I'm gonna take row 5 times row 1 plus row 3 gives you a new row 3. So I'm gonna multiply everything in row 1 by 5, add it to row 2, 3. And I have no room, so I'm gonna go to another page, but I'll keep this showing. Alright. So it is 5 times row 1 plus row 3 gives me a new row 3. Alright. 2/3, 7/3. 1, 0, 1/3, -1/3, 0, 1, 0, 0, 4, 8. So I'm gonna take everything, so 5 times 2/3 is 10/3. Right? 5 times 2 is 10, 10/3 minus 2. So 10/3 minus 6/3 is 4/3. 5 times 1 is 5, 5 minus 5 is 0. 5/3 plus 0 is 5/3. And I get a 0, I get a 1. 5 times 4 is 20.
Can you move that up, please?
I can't write it straight. There. Now, in column 2, do I have a 1 and everything else zeros?
Yes.
Good. So I'll stop for a second. Then I looked at the bottom row. Is there, now excluding this value, leave this one alone. Everything in row 2, is there any negative, I'm sorry, in row 3, is there any negatives? I'm done. Now, then you're gonna say, what are my answers? You gotta remember, this is column 1, column 2, X, Y, U, V, Z. Ready for your answers?
4,
So
8,
my
20.
X, wait a minute, my Y, my U, my V, and my Z. My X column, do I have a 1 and zeros? No, it defaults to 0. Yeah,
Slide over just a little bit, please.
this way,
Other way.
I'm joking.
Thank you.
There. Now, it has to be a unit column. And a unit column is you have 1, 1, and everything else is zeros in that column. X column doesn't have any of that, so it defaults to 0. Y column, do you have a 1?
Yes.
And everything else 0?
Yes.
Find the 1, go across. Y is equal to 4. All right, U column, does it have a 1 and then zeros? No, so U defaults to 0. V, does it have a 1 and everything else zeros?
Yes.
Find the 1, go across. V is equal to 8. Z, does it have a 1 and everything else zeros? Find the 1, go across, 20. So, your value is that Z is maximized. The value is 20. Remember how you did it on the test where it was graphed and you just found the points? My value is 20 and it's at the point 0, 4.